Hey class, just going to do a quick recap about permanent magnetism and a little heads up uh, about electricity for the next lesson on electromagnetism. So this last time you learned about permanent magnets, which are objects that retain their magnetism and create a magnetic field around them. The materials that work well for permanent magnets are substances that contain a lot of iron, nickel, or cobalt. The magnetic field is a way of visualizing the magnetic force around the magnet. And when we visualize and draw magnetic field lines, we always show them leaving from the north pole of a magnet and returning to the south pole of the magnet. And that's the direction that we draw the arrowheads on these looping magnetic field lines. A couple of other key concepts about the magnetic field lines is that they should never cross, and that the closer they are together, the stronger the magnetic field that represents, sort of like lines on a topography map representing steepness. So coming out of the North Pole, you can see that these lines are much closer together than they are at the side, which implies that an object would feel more magnetic force towards the end of the magnet rather than on the sides of these magnets. If you put opposite poles together, we know that they attract, and the magnetic field lines show that. The lines still go from the north to the south, and they actually show the two ends connecting, showing that there's an attraction between those two ends. Whereas like poles repel each other, and you can see that the magnetic field lines are repelled away from one another when you put two like ends together. Now, in order to understand electromagnetism, we need to know a little bit about electric circuits. So this is a way to represent a circuit diagram for an electric circuit that has one light bulb and a wire and a switch and a battery providing the electricity. Now we use these symbols so that we don't actually have to try to draw cartoon images of light bulbs and batteries and wires. So you may see some of these in the upcoming videos, and this is just a way to represent different components of an electric circuit. You should probably know that in order for electricity to flow, the system needs to have a totally closed circuit. So right now this switch is open, there's a gap in the circuit, and therefore electricity would not be flowing in this circuit until I close the switch here, and then you get a full loop. And once you have a full loop, that's a closed circuit, and that will allow electricity to flow. The other term that they're going to mention a lot in the videos that you watch or the tutorials you go through is electric current. Now, electricity has to do with electrons flowing through metals and metal wires, usually copper wires. Now, there's a little discrepancy there with what conventional current is. When we talk about current, it's a little bit different than electron flow. But for now, just think of it, as electrons, charged particles flowing through wires. And the current is similar to current with water, where if you had a stronger current, that would imply that the water is flowing faster. So in electric current, if you have a larger current, that means more charges, more electrons are flowing through the wire for a given time. So on the picture at the right, you can see there's fewer of these dots traveling through the wire in the same amount of time. And on the left, there's a lot more dots traveling through the wire in a given amount of time. So on the left, we have a wire that's showing greater electric current, a greater rate at which electricity is flowing through the wire. And then you could, if you hooked up your battery different, you could make the current flow in different directions through the wires. So that's going to come up in the things you talk about with electromagnetism. So we've talked about permanent magnets, and now we know some very basic concepts about electricity, which should be enough to help us out.